This is the first part of Chapter 10. We're going to be dealing with different shapes that are called conics. The different shapes are circle, parabola, ellipse, and hyperbola. The best way that I can describe why these go together is if you think about these cone shapes kind of being like jelly or gelatinous of some sort, and you have a really sharp knife, which is represented by these green squares here, and you came in to slice it. As you sliced the cone and as you lifted off the piece that you cut, imagine the piece left over on the surface of that 3D cone here. That surface would have a circular cut to it. Now, if you tilted your knife so that your cut on this cone was slanted, then the shape at the top of that cone would have an elliptical shape to it, kind of an oval shape. If you tilted your knife even further still so that your knife only went through one side and didn't touch the other side at all, it would have this parabolic shape to what was left on your cut, because it would never intersect that other side. And if your knife went straight up and down, this shape here, what was left on your cone, would be a flat surface, and this one would be a flat surface on your cone, and these ones are kind of like two parabolas, but we call these a hyperbola. So there's different slices that you can make through these cones, so we call them conics. The first one we're going to talk about today, circles, is your most basic, and a lot of what we talk about here is going to set the stage for the other shapes. The equation of a circle, you've seen this before, is x minus h quantity squared plus y minus k quantity squared equals r squared, where your center is h comma k and your radius is r. So you take the square root of what's out here. This formula is what we're going to base all of these conic shapes off of. So parabola actually looks the least like this format, but ellipse and hyperbola look very similar to this equation. So we're going to focus on how do you do the equations and how do you do the graphs, and today focusing on circles. So if you look at the graph of a circle here, write the equation in standard form. Means that you need to have the center and the radius. Well, the center we have. The center is -2, -3. The radius, however, is not labeled, so we have to look at our circle. Remember that a radius is the same, any line that we're going out, but we want to find one that we could count. So this one, heading straight upwards, goes from the center, which we know, to the edge where it hits the axis, which we also know. It goes up 1, 2, 3 units, so r equals 3. Our equation then will be x minus, but remember it's a -2, so that makes it a +2 squared, plus y minus, but again it's a -3, so that becomes a +3 quantity squared, equals 3 squared, or 9. We're going to do the same things here. Instead of looking at a graph, I've just given you the center and the radius. For our first one, you can write x minus 0 quantity squared plus y minus 0 quantity squared equals 4 squared. That's fine. Or you could also write x squared, since it's not going to give you anything different, plus y squared equals 16. Either one is good. For your next one, x plus 2 squared plus y minus 6 squared equals 3 squared, which is 9. X minus 4 squared plus y plus 5 squared equals 64. So remember, you're always squaring these radii at the end. So now let's talk about graphing. When you look at your graph, you have to identify your center, and if there's nothing written with your x value here, that's the same as a 0. Take the opposite, so it's 3. And remember, for the radius, you have to take the square root. So radius equals 4. Center first, and then take your radius out in all 4 directions. 2, 3, 4, and put tick marks. We're going to do the same thing when we get to ellipses. I'm going to ask you to take tick marks out to the side so you can see the edges of your shape. So there's our circle. Since we have labeled the center and the radius here, you don't have to label them on your picture, but if for some reason that it didn't ask you for these separately, I would want you to make sure that you label your center and your radius on your graph for me. Next one, center is positive 4, comma, negative 2, and radius is positive 3. So center and radius. Whoa, kind of an egg-looking shape here. Ah, bad circle. Oh well, that's why we give the center and the radius, so we can tell what it's supposed to look like. Good enough. All right, sometimes your equation for the circle is not given in this really nice standard form. Sometimes it looks like this. This is still a circle, but we have to get it from here to here. So one of the first things we did for this chapter is we practiced completing the square. That's what we're actually going to do here. We're going to put all of the x terms, pull them all out and put them all together, and then we're going to pull all the y terms and put them together. Any other numbers that aren't x's or y's, like this 3 here, we're going to move it to the other side, so he just sits on the outside there. But once we've grouped together the x's and the y's, now we could figure out, oh, completing the square. So what do I get when I have my completed square here? I get x plus 2 quantity squared. And I'll complete the square for the y as well, so we get a 9. And then once we have a completed square for 9, we'll have y minus 3 squared. And then don't forget to make sure that you add whatever you used to complete your squares here, you add those pieces to the other side so that we get your full radius. So we're going to practice some of this. First of all, we have a 6. We're going to have to move that over. At the same time, we're going to group together the x's. So x squared minus 2x plus box, and group together the y's. Plus y squared plus 6y plus box equals, this 6 here has moved over, so it's negative 6. I'm going to include a box for both of my sections here. All right, remember that in order to complete the square, you take half of that middle term and then you square it. So 6 divided by 2 is 3, squared is 9. Make sure we add that to both sides. And then negative 2 divided by 2 and squared will be negative 1. Squared will be positive 1. So we can go ahead and write this as something squared and write the y's as something squared. And then on this side we'll have 10 minus 6, we'll have 4. On the y side we're going to have y plus 3, and on the x's we're going to have x minus 1. Now this is, right here, standard form of your circle, but it's not asking for standard form of a circle. It's asking for the center and the radius. So our answer will be positive 1, negative 3, and r equals square root of 4. This is our answer. All right, another one for us to try. We're going to move the 7 over, group together the x's, leave a space, group together the y's, leave a space, equals negative 7 plus both those values there. Half of 8 is 4, squared is 16. Half of negative 10 is negative 5, squared is positive 25. So 16 and 25. When we factor these, we get x plus 4 squared plus y minus 5 squared equals 34. So our center will be negative 4, positive 5, and our radius will be square root 34. Decimals are okay as long as you give me the radical or the fraction to go with it. In our next one here, notice it's a little different. There's an x squared, but there's no other x term. When that's the case, that's the same as saying it's x minus 0 squared. So actually, all we have to focus on is our y part. So y squared minus 4y plus box. That 23 has moved over, so it's positive 23 plus box. Okay, half of negative 4 and square it. So we have x minus 0 squared plus y minus 2 squared equals 27. Center will be 0, positive 2. radius will be square root of 27, which we can simplify to 3 root 3. So that's what we've seen about circles, graphing and standard form. So how can you tell whether or not it's a circle if it's not in standard form? This is something that, again, we're going to do for all the shapes. When it's written out nice and long like this, you're looking for a couple things. It must have x and y. They must have a coefficient of 1, and they must both be positive. So for example, in the first one here, because the y has a negative, it is not a circle. It will be a different shape. Because in this one, there's something not a 1, the coefficient is 3, it's not a circle. But in our last one, they're both x squareds and y squareds. They both have coefficients of 1. They're both positives, so it is a circle.